The idea probably starts the same way most impossible ideas do. Someone looks up at a skyscraper, squints a little, and thinks, what if we just kept going? 100,000 floors doesn't sound like a real number. It sounds like something you'd hear in a video game or a fairy tale. But let's pretend we're serious. Let's imagine engineers, politicians, and very confident architects all agreeing that yes, this is a perfectly reasonable thing to attempt. First, we should get a sense of scale. A typical floor in a building is about 3 meters tall. Multiply that by 100,000, and your building is about 300 kilometers high. That's not just taller than any building ever made, it's taller than Mount Everest stacked on top of itself more than 30 times. The top floors wouldn't just have a nice view, they'd be peeking into the upper atmosphere, where the sky is darker, the air is thin, and the idea of opening a window becomes deeply unsettling. At the bottom of the building, life might feel almost normal. Cars drive by, people complain about the weather, someone spills coffee in the lobby and pretends it wasn't them. But as you go higher, the world starts to change. Gravity is slightly weaker at the top than at the bottom. Not enough that you'd start floating, but enough that a very sensitive scale would notice. You would weigh just a tiny bit less on the 100,000th floor than on the first. Congratulations, the elevator ride doubled as a diet plan. And about those elevators, a building this tall would not have an elevator. It would have an entire ecosystem of them. High-speed elevators, slow elevators, transfer elevators, emergency elevators, and probably at least one elevator that is always broken for mysterious reasons. Some floors would exist solely so people could switch elevators. You might live on floor 12482, work on floor 47900, and need 3 elevator transfers and a small snack to get there. At some point, riding the elevator would feel less like commuting and more like long-distance travel. Then there's the problem of weight. Buildings don't just stand there politely, they press down on the ground with their entire mass. The lower floors of a 100,000-story building would be under unimaginable pressure. The materials at the base would need to be absurdly strong, far beyond ordinary steel or concrete. Even then, the building wouldn't just risk collapsing like a stack of pancakes, it would risk slowly squishing itself, floor by floor, like an extremely ambitious piece of jelly. Wind would be another constant enemy. Up high, the wind is not a gentle breeze. It's fast, chaotic, and relentless. A building hundreds of kilometers tall would sway. Not a little bit, a lot. The top might move meters back and forth, slowly and rhythmically, like a bored giant tapping its finger. For people living near the top, this would be less architectural marvel and more permanent seasickness. And then we reach the atmosphere problem. Commercial airplanes fly at around 10 kilometers. Our building passes that point early on, maybe around floor 3000. Above that, the air keeps getting thinner. Breathing becomes harder. Fire behaves differently. At the very top, you'd need supplemental oxygen just to exist. A fire alarm on the 90,000th floor would not mean walk calmly to the stairs. It would mean hope the building has a space station-level life support system. Now let's talk about Earth itself. The planet rotates. Everything on the surface moves with it. But the farther you are from the center of the Earth, the faster you're moving through space. At the top of a 100,000-story building, you would be moving noticeably faster than someone standing on the ground below. The outward pull from Earth's rotation would still be weaker than gravity, so the building wouldn't fling itself into space, but the stresses on the structure would increase. The building wouldn't just be standing there, it would be constantly fighting the planet it's attached to. Over time, even small problems become big ones. Temperature differences between the bottom and the top would be extreme. The lower floors bake in summer heat, while the upper floors freeze in near-space cold. The building expands and contracts, bolts loosen, materials fatigue. Maintenance would never end. Somewhere around floor 60,000, a technician would be having a very bad day. And yet, suppose we somehow solve all of this. The materials exist, elevators work, the building stands. What would it be like to live there? Most people would never see the ground again. A trip to the street would be an event planned days in advance. Weather would be a concept, not an experience. People on different floors might live in effectively different worlds, separated by altitude, air, and time spent in elevators. In the end, a 100,000-story building wouldn't just be a structure, it would be a vertical planet, a place where physics changes slowly as you go up, where upstairs and downstairs stop being casual words and start meaning something profound. It would be one of the most impressive things humanity ever built, and also one of the clearest examples of us asking a very simple question and following it far beyond where common sense would normally tell us to stop.